Hello everyone, welcome back. Now in this video tutorial, let's face over a new sensor that is ADC121C. It's a very common sensor used in electronics, as you can see. To gain more knowledge about this sensor, let's have a look over website controleverything.com, and here we have to search on for this particular sensor, and let's see what we got here in this particular sensor. And as you can see, there is a long list of sensors being used. Let's pick up the basic one. As you can see, ADC121. It's a one channel analog to digital converter sensor. These are some more prominent features which you are able to see on this particular screen, and also you can purchase this sensor from here. Well, I will be taking care of the interfacing part for the sensor ADC121C with a Raspberry Pi and a Java code, and to get that code we have to go to resource tab, and here comes the Java code sample, as you can see on my screen, and you can download the code sample as a zip file from here. You can also have the code from github.com, and you can download the code from the repository, that is Control Everything Community. Now let's have a look over some connections for the hardware we need to set up. Let's have it. Well, in the hardware setup for the connections, what do we require is this Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Next, we require an I2C Shield, which you can see, and it's available on the website controleverything.com. The real reason we are using this shield is to make easier connections with other I2C devices. So for that, gently place the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. Next, we need to power up our Raspberry Pi, and for that we require a micro USB cable just like that, and gently insert it over here, the power jack. And for the internet connection, there are two options. First of all, this here is an Ethernet cable or a LAN cable. Now gently insert it over this Ethernet jack, and you are done with the connections part. Now for the other internet connection, we can also have a adapter, a wireless nano USB adapter, just like that, and you can have on the USB port. Now what we require next is our sensor, that is ADC121C, and this here is a connecting cable. Now make sure that while making the connection, we have to make the connection of the ground terminal of the sensor to the ground wire of the cable, and similarly for the I2C Shield, the same rule has to be applied. So we are done with all the connections. Now what do we require next is to have a look over the code. Well, for the interfacing section, first of all, we have to log into github.com, and then we have to check for the repository, that is Control Everything Community. Then click over here, and here comes the sensor, that is ADC121C. And this here is the Java code we are looking forward to explain. But before that, let's have a look over the instructions part. Here we have to download and install Pi4j library on the Raspberry Pi, and pi4j.com it is the link which I will open right now, and it will have the relevant procedure and the instructions to follow with the installation of the library, that is Pi4j. And after completing this installation, we have to download the code onto the Raspberry Pi, and this is the command to compile, and this is to run the Java code. Please note it down carefully. And after getting these instructions, we need to get back to the code. As for the Java, it's .java extension file. As you notice in the code, we have imported some of the libraries, and we have created a class named ADC121C021. It's for the reference, as you can see, and then we have to check for the address of the sensor to check whether it is 0x50 or not. And in the writing section part, first of all, we are going to select the configuration register 0x02, and we are going to send the command for automatic conversion mode enable, that is 0x20. Then after that, we have to read 2 bytes of the data from the register, that is 0x00, and it is raw ADC, MSB and LSB. Then we have to convert the data into 12 bits, and then it is according to the guidelines and the instructions provided in the datasheet for ADC121C, as you can see. At the very end of our code, we have to display the output onto the screen, which is the digital value of analog input and exactly the raw values. So this is how the code looks like. Now let's have a look over how it works. Well, we have come to the interesting part, that is to check for the practicality of this sensor in the code. The step is to copy this entire Java code, and let's open up the terminal for the Raspberry Pi using an internet connection. And here we have to create a new file, as you can see on my screen. it's a .java extension file for the reference, and then we have to paste the entire code here, and after that the last step is to save it, and then we have the compilation step coming here, as you can see on my screen, and we have this compilation command. The code is being compiled right now and it's done compiling successfully, and this is to run the code. As you can see, let's see what we got here. We have the digital value of analog input, which is exactly 0. It means there is nothing connected among the terminals, but instead when I connect it with the AA battery of 1.5 volts source voltage and I run the command, as you can see we have the raw value, the digital value of the analog input, which is exactly there. It's almost near to 753, 754, which is coming constant when I run the command again and again. It means the cell voltage is there, the raw value will be there. So this is how the sensor works. Now the next step is to look over the features and the applications of this sensor. The ADC121C and the family of ADC121C021 is a converter that is low power monolithic 12-bit analog to digital converter that operates from a 2.7 to 5.5 volt supply. The converter is based upon a successive approximation register architecture with an internal track and hold circuit that can handle input frequencies up to 11 MHz. The device features an I2C compatible serial interface that operates in all 3 speed modes, including high speed mode 3.4 MHz. Due to these good features, it is applicable in a lot of applications like system monitoring, peak detection, portable instruments, medical instruments, test equipment, automotive, and a lot more to mention. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.